Let's see, Emily, what were we talking about last time? Emily King.
The long division algorithm.
Right, we're working on this long division algorithm. Okay, now we know that's a little bit later in primary school, but it's really important. It's a challenging algorithm for the students to learn, but it's one of the most important that they will learn because it really shows, one, what an algorithm is, and it has the added feature of giving a nice demonstration of the power of successive approximations. Okay, every stage you do in the division algorithm gets you a little closer to the actual answer. So even if you have to stop partway through, you've still gotten some progress. Okay, I want you to try something here. I didn't mean to do that. I meant to do that. Okay. So I believe this is section 3.5. So we're going to do a little warm up. Okay, I want you to try this in your own notebooks. I want you to do a long division problem. I want you to take 6 and I want you to divide that into 372. All right, take 2 minutes. That should be more than enough time to write out the answer to this problem. Okay, I know I said 2 minutes, but I'm getting bored. So, Carson, help me out here. What do I write first?
You would write 7.
Okay, up here.
Yes.
Okay, now I think you've overshot it a little bit because
Oh wait, no, sorry. 6.
yeah, 6 is what I need. Okay, so so we adjusted our answer there. So why doesn't 7 work?
Because it would be
40. Yeah, it gets us to 42. Okay. So let me see. So I start out by writing a 6 up here. And Kelsey, help me out here. What do I write underneath?
36.
Right, we're writing 36. Now, why are we putting a 36 there?
Because 6 times 6 equals 36.
Right, 6 times 6 is 36. And then we subtract. 37 minus 36 gives us 1. And then we drop down this 2. Okay, let's see. Macy, what next?
You would put 1 or 2
Yeah,
by
we can get a 2 up there. And since we're putting a 2 here, what does that mean we put down here?
You would subtract 12.
Right, so because 6 times 2 is 12, we put a 12 here. We subtract 12, we get a 0. So the division actually works out to go in evenly, and we can stop. All right. So remember, as teachers, we kind of really need to think about why we're doing the steps we do, and that's especially challenging with elementary mathematics, because we've been doing elementary mathematics for years. Okay, it's kind of ingrained, and we almost do it without thinking about it. Now that's good, because if you can do something without thinking about it, that frees up working memory to think about other things. Okay, so your students will eventually need to get to that point, but they're not going to start out at that point. So it's our job as teachers to help them along to that point. And in order to do that, we need to think about why we're doing the steps that we do. And we need to think about why we do the steps that we ordinarily do without thinking about them. Okay, so let's kind of analyze our thought process here. So the first thing we decided was there had to be a 6 over here. Now let's kind of go back again. Madeline, help me out here. Why did we put this 6 here again? I think I might have mentioned it, but I forgot. What was it? So when we started this process, we decided to put a 6 there. How did we decide to do that? Okay. I don't know if I have to, in good oh, go ahead. Somebody had something? No?
You put the 6 there because it was the largest number that could be multiplied by the 6.
Okay, right. And keep us under 37, right? So initially somebody mentioned, well, maybe we should try 7 there, but then we realized, oh, that goes too far. 6 times 7 is 42. We need to get as close as possible to 37 without going over. So basically the reasoning is because 6 times 6 is 36, and this is as close to 37 as we can get without going over. Okay. And then over here, the 2, of course, is because now we're looking down here, we're looking at this 12. We're thinking, okay, what can I multiply 6 by to get 12? And that's 2. Okay, so the idea is that because we know the multiplication table for 6 we can work this problem. Okay, because we know which multiple of 6 will get us closest to 37, we can do this. Now, if you remember from last time, we had discussed the stages for teaching the long division algorithm. And the first stage is dealing with single digit divisors. Since students who would be learning the long division algorithm have already worked on multiplication, they will know their times tables and they'll have this information. The question is, when you're transitioning to multi-digit division, what do you do then? So I'm going to talk about some key ideas here. So the overarching key idea for this lesson is going to be estimation. applying to multi-digit divisors, but really we're just going to talk about 2-digit divisors. And then we'll talk about strategies that we could use for getting the best estimates. Okay. So I want to kind of do a transition problem here. Okay, let's say we had this long division problem. We're taking 16 and we're dividing into 9,152. Okay, now remember, the whole point of an algorithm is that it solves a class of problems. Okay, so the long division algorithm should allow me to take any number I want and divide it into any other number, figure out the quotient and the remainder. So in particular, I should be able to use it to figure out this. Now, the reason that our previous problem here was easier, I'm sure most of you could have done this in under 1 minute. The reason this is easier is I know my multiples of 6. Okay, 6, 12, 18, 24, 30, 36, 42, 48, 54. Okay, and that's all I need to know because that's 6 times 9. Okay, 6 times 10 is 60, but you'll never have to put a 10 in any of the place values. Okay, so I know my multiplication table for 6, but I don't know my multiplication table for 16. Okay, so in order to do this problem, let's try this. I will make myself a little multiplication table. All right. This one's super easy. We can fill in this table using a lot of mental math. Help me out here. 16 times 5. Okay, who have I picked on? Or it's a mystery person. Micah? Who's Micah?
That would be me. I'm sorry. My
that's
boyfriend
okay.
had to borrow my laptop for another class.
No, that's fine. No, I
It's
figured
Amy.
I figured it was something like that.
Sorry about that.
So Amy, help me out here. I'm looking at doing 16 times 5. I think we had a mental math strategy for multiplying by 5. What was it?
Multiply by 10 and divide by 2.
Right, multiply by 10, divide by 2. And you could also reverse those. So here, it's probably easiest to divide by 2 and then multiply by 10. So either way, what do we get?
80.
80. Okay, great. So 16 times 5 is 80. That actually helps me out for 16 times 6. Let me see. Gosh, where was I? Okay, Rosie, help me out. If I know 5 copies of 16 get me up to 80, what would 6 copies give me? Right, 96, right? So
96.
yeah, good. We can start here and add 16 to that, getting us to 96. Okay, let's actually skip around here a little bit. Let's jump to this because we have a strategy for multiplying by 9. Let me see. Cynthia, do you remember the strategy for multiplying by 9?
No, I don't.
Oh, okay. Let me see. Emily Skipworth, Do you remember our strategy? Can you help us out here? We're trying to multiply by 9. There was a technique we could use.
I don't know either. I'm
Oh,
sorry.
no. Let's see.
Don't
Would it
you
be
Okay, go ahead.
don't you add it or times it by 10 and then minus
Okay,
16?
right. So the strategy for multiplying by 9 is multiply by 10, okay? And of course, multiplying by 10 is easy because we got a place value system, base 10. So if I want to do 16 times 9, I should do 16 times 10, which we can do mentally. That's 160. So that's 10 copies of 16 would get us to 160. Now we don't want 10 copies, so we got to back off by 1 copy of 16. So to get 16 times 9, I start with 160, and then I back off, take away 16, okay? 16 is 10 and 6, right? So if I do 160, take away 10, I'm at 150. Now take away 6, 1, 4, 4. Okay, this one's super easy. 16 times 2, what do we get?
32.
32. How do we get that? What's the strategy for times by 2?
Double it.
Double it, okay? What's the strategy for times 4?
Double, then double again.
Right, double, then double. Okay, so what should I put here?
64.
64. Okay, what question am I going to ask next?
Sixteen times 8,
Right, that's the next one. Why are we asking that one next?
because you doubled 3 times.
Right, so double once, you get to 32. Double again, you're at 64. Double a third time, and we are at
128?
128. Okay, now that we have this, how can I get 16 times 7?
128 minus 16.
Right, if 8 copies of 16 get us to 128, then 7 copies would be, let me see if I can do this here, 1, 1, 2, is that right? Take away 16? Yeah, I think so. Okay, so the only thing left is right here. We don't really have a strategy for multiplying by 3, but we can use the work that we've done to figure this answer out. How can I use what I have written down here to figure out what should go in that spot?
You would add 16 to 32.
Right, we start here. That's 2 copies. We want 3 copies, so add 16, and you get 48. Okay, so a little bit of a review of our mental math techniques. You are going to need to do considerable mental math when you're doing the long division process. Even when you're doing the pencil and paper long division process, you're going to need to do some mental math. So we are going to keep reviewing those techniques. And I think I'm going to work on doing some mental math quizzes when we get back to classes on campus next week. Looks like the snow is going to melt quite a bit this weekend. Might be completely gone by Monday, so everything should be good for getting into school. Okay. So that was a bit of a digression, but there was a point to it. The point was we were supposed to do this long division problem. Okay, so help me out here. How do I use this information to help me figure out this long division problem?
You can see what number times 16 gets you close to 91.
Okay, right. We're looking at 1691. What multiple of 16 gets us closest to 91 without going over? And that was sort of the, 5, right? That was sort of the whole purpose of writing this out. Obviously, we would write it out just because it's fun to write out multiples, but we needed to use it here. Okay, so we should do a 5 there. We just figured out 5 times 16 is 80. So we have 1, 1, 5. Okay, now what?
You would do 7 because it's 112.
Right, we're trying to get as close as possible to 115 without going over. This is too big, so we would need to go to 112, which we can do by multiplying by 7. So 1, 1, 2. And then that's a 3. Bring down the 2. And now we can finish it off there. We know 16 times 2 is 32. Okay. Now, the whole reason I wanted to write out that, oh gosh, that washed out really badly. You can't see nothing. Okay, the whole reason I wrote out that multiplication table was so that we could see which multiples of 16 we needed to use. Now, the idea when we're doing this 2-digit division is this is a pain in the butt to write out every single time. If I had to write out the multiplication table for my 2-digit divisor every time, it would be super tedious. But of course, we don't remember the multiplication table for all 2-digit numbers. That'd be too much to remember, right? You got 90 2-digit numbers because you're talking about going from 10 all the way up to 99. Okay, I guess it's 89. No, it's 90. 90 different numbers. That's way too much to remember. So the idea is that we can use estimation to help us. So we're going to use estimation to avoid writing out the multiplication table each time. Okay, so let me give you an example here where we apply that multiplication estimation. Okay, so I'm going to take 29 and I'm going to divide that into a really big number. Okay, 1, 6, 5, 0, 0, 1, 8, 8. Okay, really big number right here. So a couple things. Obviously, we don't need to worry about these right away. Okay, we're only focusing on the beginning part. Okay, so there's no need to be intimidated by this thing being a big number. We're never going to have to deal with dividing 29 into this whole thing at once. Okay, now, gosh, the multiplication table for 29, I don't know what it is. But here's my thought process. 29 is really close to 30. Okay, that's what this wavy equal sign, it means approximately. Okay, 29 is approximately 30. Now, the multiplication table for 30, well, I actually have that in my head because I know the multiplication table for 3. I just need to take all of those numbers and tack a 0 onto the end. Okay, so let's get started with this big long division problem. 29 into 165, no idea. What multiple of 30 will get me closest to 165? Thirty times what?
30 times 5.
30 times 5, right? That gets us to 150. If I did 30 times 6, I'd be at 180, so that's too big. Oh, and of course, I might have skipped over this step, but right, 29 does not go into 16. That's why I jumped right to 165. Okay, and when we're doing this long division, we need to be careful about the place values. Okay, that 5 should go up here. Okay, so we're using the estimates to kind of get us started on this process. Okay, now 29 times 5, I need to know what that is. I can't just pretend this is a 30 and then do the math that way. Okay, it's not going to get me the answer. Okay, well, if I know 30 copies of 5 get me to 150, where would 29 copies get me?
$145.
Right, 145. So we know 30 copies get us to 150, so back off one copy of 5, 145. Okay, so that's a 2, that's a 0. 29 does not go into 20, 200. So we're thinking of what multiple of 29 is going to get me as close as possible to 200 without going over. And of course, to figure that out, we estimate what multiple of 30 is going to get me as close as possible to 200 without going over.
Six.
Right, 6, because 6 times 30 is 180. If I went to 7, 7 times 30 would be 210. So that's too much, so we use 6. Okay, so now we're going to use the same technique, because we can't put a 180 down here, right? That's not true. Okay, that's what we were using to get started. That's not the actual answer, but the 180 can help us. I should have 174 here. Let me see here. Let's see, Tasha, why would I have 174 here rather than 180? How do I get the 174?
29 times 6 is 100.
Right, 29 times 6. And the way I was doing it, I took 30 times 6, 180, and then took away a 6 from that, back off 6. Okay, now I need to do a subtraction. Okay, we know our subtraction algorithm. What should I do? Got 0, take away 4, can't do it.
Take away 1 from the 2.
Okay, right, we're gonna have to kind of borrow through a couple places. So that's now a 1. This becomes, I'm gonna do that. I put a 9 there, and then I'm putting a 1 over there, okay? So I unbundle in my hundreds place. That gives me 10 in my tens place. And I'm going to unbundle that to give me 10 in my ones place. Now I can take away the 4, that's a 6, that's a deuce, that's a 0. 260. Okay. We're talking about 29 going to 260. Think about multiples of 30. Okay, 30 as close as possible to 260. Can I do 9? Will that work?
No.
No, why not?
It's too much.
Right, it's too much. What's 9 times 30?
270.
Right, 9 times 30 is 270. That exceeds our target there, so we should probably go with 8. Now 8 times 30, that's 240. Okay, so 8 times 29, 232. Right, notice I'm using my estimates even to get these numbers right here. Okay, so this is 28, 281. Okay, I think I can do 9 now. Okay, Now 9 times 30 would give me 270, which is still less than my target of 281. But I don't want to do 9 times 30. I want to do 9 times 29. So I do my 270, 261. 2, 0, 8. Okay, I want you to take that 30 seconds, maybe a minute in your seats, in your notebooks at home, finish off the rest of this problem. Remember, we're thinking about 30 when we decide what number to put up there. Okay, so let's see here. So what should I put next? What's the next number that goes up top here?
7.
Right, we should use a 7. We're looking at 208. We're thinking about 30. 30 times 7 is 210. Okay, but of course, we don't want 30 copies of 7. We only want 29. So that'll be 203. And then 58. So the last thing here should be a 2. 2 times 29 is 58. So it gets us to 0. Okay, and then of course, at this stage, we know that we're done. Okay, we've gotten to the last digit. Okay, so estimation was essential to figure out what should go up here in those various spots. And it also helped me figure out what to put down here. Right? Because the way we got to 145, we said, okay, 30 copies of 5, we know that's 150. If we only want 29, we should do 5 less than 150. That's how we got to 145. 30 copies of 6, that's 180. We only wanted 29, so we should start at 180 and back off 6. Same thing with all those. Okay. So estimation. Is the process of finding an approximate answer to a given computation. Estimation is the process of finding an approximate answer to a given computation. Okay, so the uses of estimation. Well, sometimes you only need an approximate answer. Sometimes that's good enough. If you're checking a complicated computation to make sure your answer is in the right ballpark, then estimation can be helpful. And essentially, this is the other thing to get you started. On your way to finding the exact answer. Okay, in our work with that long division problem, the estimate of dividing by 30 is what got us started each time. Okay. Actually, if I were to answer a question like this, let's say something is 400 minutes. Let's say we got 400, let's say we're doing prepaid cell phone, something like that. We buy 400 minutes. How many hours are we talking about? Well, the exact answer would be figured by doing this. Okay, why am I dividing by 60 here? What's going on there?
There are 60 minutes in an hour.
Right, 1 hour is 60 minutes. So if you have 400 minutes and you're wanting to find out how many hours that is, well, you would divide your number of minutes by 60 to get the answer. Now, if I'm only concerned about an approximate answer, here's what I would do. I would say, all right, you want to do that? Let's actually do this instead. Okay, now why would I change this to 420? What's going on there?
Because 60 times 7 equals 420.
Right, right. I'm thinking about, okay, my multiples of 60. And in fact, of course, I don't even need to think about multiples of 60. I just need to think about multiples of 6 because the zeros would cancel each other out if I did this division. So I don't need to worry about them. I just need to know, okay, what multiple of 6 is closest to this right here? Okay, so 36 is kind of close, but 42 is even closer. So let's use that. And the whole point is that computation is something that we can do easily. Okay, so the answer to this is you got about 7 hours in 400 minutes. Here's another example where estimation comes in handy. Now, I'm not going to ask you to do this calculation. Okay, but let's imagine we're doing our science class and we have to do a computation like this. That comes up a lot in things like chemistry and physics and whatnot. Okay, so you got to do this complicated computation. How do you know you didn't make a mistake and put the decimal in the wrong spot when you did that? Is there any way you could get a ballpark to what this should be about? What should it be close to after we do the computation? Well, here's how I would do it. Okay, let's do this. Instead of doing 123.234 times 1.8873 divided by 3.256, let's do this. Now, obviously, I would do this on a calculator, but I can do this one in my head. Okay, so what would I get from this?
Eight.
Right, right. So I really just need to do, you could do the multiplication first. You got 240 up top. And then I really don't need to know 240 divided by 3. I just need to know 24 divided by 3. The answer is 80 there. Okay, so the reason this is helpful is I said, yeah, I'm going to do this on my calculator. Now, the calculator will do the exact computation you tell it. If I put that decimal in the wrong spot, it's going to do that computation. Okay, the reason this is helpful is I can check, is the calculator giving me something that's about 80? If it is, then I probably entered this correctly, and I can be a little more confident in my result. In other words, this is the ballpark figure for this computation. So yeah, I'd use a calculator, but now I can check to see if I put my computation in right. All right, let me see. If you've got, where did I, oh, here it is. It's under my notes. Okay. If you've got your 5A workbook, this thing, Primary Math 5A, do me a favor and open that to page 16, sorry. Let's do page 16. Whoops, I went away. There I am. Okay, page 16. Slide that over there. Okay, they're talking about estimation with these problems right here. Oh, no, down here, estimation. Okay, so for something like this, and here they're explicitly asking for an estimate. Okay, they say, okay, estimate the value of this. All right, well, 702, pretty close to 700. 19, pretty close to 20. So what's the answer to this? What is 700 times 20?
$14,000.
Right, 14,000. And of course, we just need to know 7 times 2. Okay, 7 times 2 is 14, and there were 1, 2, 3 zeros in this multiplication problem, so we just tack those 3 zeros on. So it would be a 14 followed by 3 zeros. Okay, here's a little word problem for getting an estimate. So we're imagining we've got a school parade or something like that. So we have 543 costumes that we need for students in the parade. And let's imagine the costumes each cost $35. Okay, so this is a quick way to get an estimate. 35, okay, well, let's round that up to 40. Let's do the nearest 10. Okay, now here we don't do the nearest 10, we do the nearest 100. Okay, the reason is you're allowed to pick what you do for an estimate. Okay, so 40 times 540 would be easier than 35 times 543, but this is even easier. Okay, so if you're doing estimates, I mean, make your estimates as easy as possible. Make your estimates 1-digit computations. 40 times 500, 20,000. How do we get that? Well, 5 times 4 is 20, right? Notice these are not bold and these are. Notice the zeros up here were bolded, 1, 2, 3 zeros in the problem. Do 5 times 4, get 20, tack on 3 zeros. All right, so if you want to buy costumes that cost $35 each for 543 kids, you're going to need in the neighborhood of $20,000. Okay, that's a quick estimate. Okay. So as far as these estimates, this is probably the easiest one to do. What should I do with this? How would I get a quick estimate for this computation?
8,000 times 60.
Okay, right. Take this to the nearest thousand, make it 8,000, not 7,804, 8,000. And then of course, this goes to the nearest 10. 8,000 times 60 is 48,000, 48,000. So the estimate for that is $48,000. Something like this, I would take that up to 80 and take that up to 400, 80 times 400. Here I might go 500 times 30, and I would do that computation if I wanted to get an estimate. Okay. So I would like you to read through Elementary Math for Teachers. Whoops, no, where am I? Come on. Here I am. Okay, so Elementary Math for Teachers, section 3.4. No, section, well, if you haven't read through section 3.4, make sure you do that on long division. Okay, we are going to have a quiz on Monday, I think, right? Look at your grid. I think Monday is going to be a quiz. Okay, so if you haven't read through section 3.4, make sure you do that and go through 3.5, which is 77 through 81. And then do the homework problems on page 81, 1 through 6 on page 81. Okay, so I will see you guys in person on Monday. If you need to know which group is in there, look back at your Canvas messages. I sent out a copy of the grid with which group is going to be in class on which day. So we'll just kind of pick it up based right on that, okay?
What group goes on Monday?
Let me look at my Canvas messages here and I'll see. Okay. Let's go to structural concepts. Does it tell me which ones have attachments? No. Oh, I'll just look at my Dropbox here. I think I've got the schedule there somewhere. Yoink. Dropbox. 2021 spring, structural concepts. Okay.
It's group B.
Oh, okay, it's group B. You found that somewhere in one of your messages? Okay,
Yeah.
thanks. I was having a little trouble finding it. Okay, so group B on Monday. In fact, maybe I'll just send out a message. I'll look for that. I'll look for that copy and I'll send it out again. Okay, thanks a lot.
Okay.
Thank you.